Okay, so in this video I'm going to go over the practice quiz that's on Canvas. I printed it out on paper so I can work through it, but it's the same thing. So number 1 wants me to find the real solutions of the radical equation and then to round my answer to the hundredths, which is 2 decimal places. So I want to start off by subtracting 17 on both sides. Then I get x to the 5th. 35 minus 17 is 18. And then I want to get rid of this 5th exponent. So what I want to do is I want to raise it to the 1/5 power. On my left side of the equation, the exponents cancel out. And then on the right side, I just need to go ahead and go to Desmos and type that in. So give me a second to pull up Desmos. So I want to do 18 to the 1/5 power, which is 1.78. If this 2 was a 5 or more, I would want to round up, but I don't. So it's going to be 1.78 for my answer here. This is a box. Okay. The next question, again, wants me to find the real solutions of the equation, and then to round my answer to 2 decimal places when appropriate. So this one I want to raise it to the 1/4 power. X minus 3, or actually the exponents cancel out on the left side, so I'm left with x minus 3. Whenever I have an even exponent here, so that 4, because it was even, my answer when I take the root is going to be plus or minus. And then the 4th root of 81 is 3. Yeah, I could find this by typing it in on Desmos if I didn't know. Then because I have a plus and minus, I want to go ahead and split this up into 2 equations. So I'm going to have x minus 3 equals 3, and x minus 3 equals negative 3. Then I want to go ahead and solve each equation for x. On this one, I want to add 3 to both sides. I get x equals 6. Over here, I want to add 3 to both sides. I get x equals 0. So 6 and 0. This one wants me to evaluate using a calculator, so I just need to go ahead and go to Desmos and type this one in. So I have 40, this one is 48 to the 2/7. Remember, to get an exponent on Desmos, I can either do Shift 6 or this little keyboard down here. If I click on it, there is an exponent button here. I would press the A to the B to get an exponent. So anyways, my answer here is 3.02. And that one I just get from typing into Desmos. Okay. Number 4 is a little cut off the page, but that's fine. It wants me to simplify the following radical expression. Because they are both 4th roots, I can go ahead and rewrite this as one giant radical with the fraction inside. So 208 over 13. Then I want to actually go ahead and divide 208 by 13, which gives me 16. So I have the 4th root of 16. Then I want to go ahead and factor tree my 16 so I can actually find the 4th root of it. And I have 4 2's, so I can take the 4th root nicely, and my answer here is just 2. Moving on, this one is given this equation, so the standard form of a cube root. How is it translating the graph with h units? So what does the h in the equation do, basically? Remember, the a out front is a vertical stretch if it's larger than 1. It's a vertical shrink if it's between 0 and 1. H is moving left and right, and k is up and down. So when it's moving h units, it's moving left and right, which is a horizontal shift. Okay, this one is going to be on 2 different pages, and it printed back and front. So here is my function a. I'll move this for a second. And it is the square root of 3, or square root of x plus 3 minus 7. So what I want to go do is I want to go to Desmos and type this one in. X minus 3 minus 7. So if I take a look, Actually, it's plus 3. If I take a look, the graph starts here at -3, -7, and then goes up forever and right forever. So domain is left and right, so it starts at -3 and goes right forever. So all numbers greater than -3 for domain. And for my range, it starts at -7 and goes up forever. So all numbers greater than or equal to -7. So this one, I want to go ahead, and there is a drop-down choice for this. But for domain, I want x is greater than or equal to -3. And for range, I want y is greater than or equal to -7. And then I want to do the same thing for b. So let me go back over here. This one is a cube root. CBRT to get the cube root to show up on Desmos. Or if I click this keyboard, I thought it was here. Yeah. If you go to functions and then miscellaneous, there is an nth root where you can type in your own number. But going back here. Let's try the keyboard. This one, notice if I zoom out, it goes left and right forever, and also it's slowly going up and slowly going down forever. So this one, my domain and my range, because it's going in both directions forever, is all real numbers. So on this one, there is a choice that says all real numbers. Function C is on this paper, so I can go ahead and type that one into Desmos. This one, let me go back and press home so it zooms in. This one starts at +3 and goes right forever, so my domain is going to be x is greater than or equal to 3. And then it starts at -7 and goes down forever, so it's going to be less than or equal to -7 for my range. So we go back to the paper so you can see what this looks like. And it's less than because it's going down. Then I want to go ahead and type in my last function, which is the same one I just typed in without the negative out front. This one starts at 3 and goes right forever. And then my range, notice, is flipped. Instead of going down, it goes up forever. So this one is going to be x is greater than or equal to 3. And then my range is y is greater than or equal to -7. One thing I forgot to say is when I have a cube root like I did for b, it is always going to be all real numbers for both the domain and the range. I spelled roots wrong. So remember, whenever you see a cube root, that answer is always going to be all real numbers for both the domain and range. Moving on. Now number 7 wants me to go ahead and solve this one. So I want to get rid of this fourth root by raising it to the 4th power on both sides. The root is going to cancel out with the exponent, and I am left with x minus 5 equals 2 to the 4th power is 16. Then I want to go ahead and add 5 to both sides, and I get x equals 21. So my answer here is just 21. Moving on. This one again wants me to solve for x. It is two square roots equaling each other. The way we get rid of square roots is by squaring. So I can square both sides. I get 2x plus 5 on the left and x plus 7 on the right. Then this is just a normal linear equation for me to solve. So what I want to go ahead and do is I want to subtract x on both sides. I get x plus 5 over here equals 7. And then I subtract 5 on both sides. And I get x equals 2. So 2 is my answer. Number 9 tells me that the equation has an extraneous solution. And it just wants me to tell how I know if a solution is extraneous. I don't actually have to go out and solve it, but I am going to solve it to show you what an extraneous solution is. So if I squared both sides, I am really having a binomial squared. So I have x minus 4 times x minus 4. On the right side, when I square it, it's just going to be 2x plus 7. And then, that was the left side. On the right side, I have x times x, which gives me x squared. X times negative 4, which gives me negative 4x. Negative 4 times x gives me negative 4x. Negative 4 times negative 4 is 16. Then I have 2x plus 7 equals, I want to combine like terms on my right side. So I have x squared minus 8x plus 16. I want to subtract 2x on both sides. I have 7 equals x squared minus 10x plus 16. I want to subtract the 7 over. I get x squared minus 10x plus 9. I want to factor this. I'm looking for what multiplies to positive 9 and adds up to negative 10. This is going to be negative 9 and negative 1. Then I can take each of those and set them equal to 0. So I have x minus 9 equals 0, x minus 1 equals 0. Solve for x. I get x equals 9, x equals 1. Then what I want to do is I want to go ahead and check my answers. So I'm going to pretend this part of the box isn't something I can write on. So I'm going to start by plugging in 9. I have 2 times 9 plus 7 equals 9 minus 4. The square root of 2 times 9 is 18 plus 7 should equal 9 minus 4 is 5. 18 plus 7 is 25. The square root of 25 is a positive 5. So this answer works. Then when I go ahead and plug in 1, I get, under the radical, square root of 2 plus 7 equals negative 3. We can't have a negative number, so this one doesn't work. So only 9 was an answer. So what it means to be an extraneous solution, 1 is an extraneous solution, it means it doesn't make the equation work. So I'm going to write an extraneous solution is one that doesn't make the statement true. Moving on. This one gives me two functions. It wants me to add the 2, subtract the 2, plug in 8 to the addition function, plug in negative 27 into the subtraction function. So for adding the functions, I have 4x to the 2/3 plus negative 7x to the 2/3. So basically, because I have a plus sign, I'm just going to add those two numbers together. 4 minus 7 is negative 3. And then my x exponent stays the same. So my answer for the first part is negative 3x to the 2/3. Then I have the subtraction problem. So I take the two functions and I subtract them. When I have a double negative here, I want to go ahead and add them. So really I have 4 plus 7, which will give me 11x to the 2/3. Then the third part wants me to plug in 8. So I have negative 3 times 8 to the 2/3. I am plugging in 8 into my answer from the first part. Then I want to go to Desmos to type this in. Which gets me negative 12. On the last one, I want to go ahead and plug in negative 27 for my subtraction one, which was the second one I wrote. I have 11 times negative 27 to the 2/3. So where did my Desmos go? which gives me 99. Number 11, the question is here, but my writing space is on the next page. So it says the boat's speed is modeled by 4.62, ninth root of n, where n is the number of rowers. A wants me to find the boat speed for 2 people, and then B wants me to say if the boat speed doubles when the number of rowers double. So, for A, I will plug in 2, so I have 4.69 times the ninth root of 2. If I want to type this in Desmos, I can use the ninth root option. I can use the nth root option to type in 9. Or another way I can type this is 4.69 times 2 to the 1/9 power. Both of these expressions are the same. It's just a different way of rewriting it. So then I want to go to Desmos and type this in. Nope, 1/9. Which gives me, I got this number wrong. It was 62. My bad, I misread the problem. So, this rounds to 4.99. So if I go back over here, it's going to be 4.99, and then it was meters per second. B wants me to say if the speed doubles when I double the number of people. So twice as many as 2 people is 4. So I'm going to plug in 4 and see if my speed doubles. So if I go back to Desmos, I'm going to change that 2 to a 4, which gives me 5.39. $5.39 is not twice as much as 4.99, so this one is no. When we doubled 2, the speed didn't double. My next question wants me to match the function with its inverse functions. So what I'm going to do is I'm going to solve each of these functions and then find the matching inverse over here. So for number 1, you always want to switch your x and y. So I'm going to have x equals 2 cube root of y minus 2 plus 5. Then I want to start unwrapping everything so I can get y alone. I always start by undoing addition and subtraction. So I'm going to subtract 5. And I get it equaling 2 cube root of y minus 2. Then I want to divide by 2 on both sides. I get x minus 5 over 2 equals just the cube root of y minus 2. I want to go ahead and cube both sides. Notice on these answers, just the top part stays written like that with the exponent. I don't actually have to cube it out. And then 2 cubed is 8. I could type that in Desmos if I didn't know it. And then I have it equaling y minus 2. To get y alone, I add 2 to both sides. So I have x minus 5 cubed over 8 plus 2 equals y. So this is minus 5 over 8. This is D. Then I want to go ahead and do the same things for my other 2 radical equations. So just let me grab another piece of paper to keep working on. So number 2 was switching my x and y. I get x equals 4 cube root of y minus 3 plus 2. I want to go ahead and start by subtracting 2 on both sides. I have x minus 2 equals 4 cube root of y minus 3. Then I want to go ahead and divide both sides by 4. I get x minus 2 over 4 equals the cube root of y minus 3. I want to get rid of that radical, so I cube both sides. I get x minus 2 cubed over 4 equals y minus 3. Then I just want to go ahead and add 3 to both sides. So I get x minus 2 cubed over 4 plus 3 equals y. So if I take a look, this is minus 2 plus 3, this is c. Then I want to go ahead and do the same thing for 3. So this one, I'm switching x and y. So I have 3x. The third one is x equals 2 cube root y minus 5 plus 4. Start off by subtracting that 4 on both sides. I get x minus 4 equals 2 cube root of y minus 5. Then I want to go ahead and divide both sides by 2. I get x minus 4 over 2 equals the cube root of y minus 5. Then I want to go ahead and cube both sides to get rid of that cube root. That gets me x minus 4 cubed on the top. 2 cubed is 8 equals y minus 5. Then I want to go ahead, add 5 to both sides. So I get x minus 4 cubed over 8 plus 5 equals y. So this one, oh, I already used that one, is B. So if I notice, this ending number opposite the sign was the answer choice in here on the top part in the parentheses. The inside number changed sides, signs, and went on the outside. And then this number that it's being multiplied by is the number cubed on the bottom. So those are some hints to help you figure it out if you look at this later and get stuck. The next one gives me two functions and asks me if they're inverses of each other. The way I do this is I take this and I plug in for the x value here. So I have 4x plus 3 that I am going to plug in for my g of x. Because I have parentheses on my numerator, I can go ahead and just, parentheses with addition and subtraction, I can just add. Positive 3, negative 3 cancels out. I have 4x over 4, which cancels out even more and gives me x. So that one works. Then I want to take this and make sure it works the other way too, and plug in for the x over here. So I have 4 times the quantity x minus 3 divided by 4 plus 3. Then I want to go ahead. I have the 4 here and the 4 on the denominator. Those cancel out. I get x minus 3 plus 3. That cancels out, and I just get x. So this worked on both times when I checked it. It gave me x out. So I'm looking for a yes answer. So I know this one's not it. And then it gave me x both times, like it should. It should always, if it's going to give me x, it should always give it to me both times to be an inverse. So this is my answer. So whenever I look at these problems on the test, it should either be yes because of and, or no, because one of the ones doesn't equal x. Okay. Number 14 is kind of, it's just missing a. So I'll rewrite it. Function a is a to the first power. So let me white out the title name of the page so you can see what I wrote there. A to the first power. Okay. So what this one wants me to do is name all of the pairs, and there are 3 different pairs, and I assume any variable is positive. So I want to look for what matches up to function a. So which of these is equivalent to a to the first power? So I'm going to go through this list and rewrite these. Whenever I have an nth root, to an nth power, the exponents cancel out and it's just the variable. This one is the same thing as a to the first. So this one, my answer is C. On D, when I have a negative exponent, it's the same thing as writing 1 over a to the same exponent. On function E, I can rewrite this as just the square root of a, and then to the n. You can write it without the exponent. I could also move this exponent inside the radical, so it could be the square root of a to the n. Over here, I could rewrite this so it's just the square root of a, and then overall to the nth power. The exponent and the radical can switch places if there's only one thing on the inside. G, I can rewrite this as a, why did I write G? As a to the 1 over n, because n is my index on the radical. And then there really is no way to rewrite h. So, I want to next compare b and see which one is also like b. B was a to the 1 over n, which we got for G. So G is my matching pair. E is the square root of a to the nth power, which I got to match up with F. So those are my matching expressions. Number 15 is telling me it's the volume of a sphere, and it gives me this equation where V is the volume, R is the radius. It wants me to solve for R and determine the radius of a sphere with a volume of 400 pi cubic meters, and then to put in my answer rounded to 2 places. So what I'm going to do is, this is my volume, so I'm going to plug in 400 pi for V. Then what I want to do is I want to get rid of the numbers in front. Remember, whenever I have a fraction, the way you get rid of a fraction is you flip it and multiply it. So I want to multiply it by 3/4 on both sides of my equations. It's going to cancel out on the left. And then if I do 3/4 times 400, gives me 300. So if I go back to my paper, I have 300 pi equals pi r cubed. Then I want to go ahead and divide out pi on both sides. It's actually going to cancel the pi's out. So I just have 300 equals r cubed. Then to get rid of my exponent, remember I raise everything to the 1/3 power. So I want to go type in 300 to the 1/3 power, which gets me, the parentheses, gets me 6 point, this one is going to stay 69. Okay, so that is it. Make sure you study, and then good luck on the test.